Okay, so in this video, we'll be discussing October-November 2024, paper 6.2 for probability and statistics 2. So let's have a look for question number 1. Alright, so we are given a random variable x with the distribution of binomial and asks us to use a Poisson distribution. So I highlight the keyword Poisson to calculate an estimate of the probability of x greater equals to 4. Okay, so they give us a very clear instruction already. We are having binomial at first, and they want us to change it become Poisson. So let us start. This is the original binomial here. So 4.5 million, right? Okay, so divided by 1 over 1 million. Okay, and then what do I have here is we have to change it become Poisson. So for your information, just in case that if you want to know, why can we change a binomial distribution to Poisson distribution? Okay, so we can do this when it fulfills the condition here. The first one is your n must be large enough, which is greater than 50. And the second condition is you have to make sure that n times p is smaller than 5. So these are the two conditions that must fulfill by a binomial distribution. Then only you can change it become Poisson. Alright, so we are going to change it become Poisson. So for the Poisson here, right, the parameter inside here will be a lambda. Lambda means the mean. Okay, so what is the mean that we have here? How can I get the mean from a binomial distribution? So to get the mean from binomial distribution, you have to take n multiply with the p. So you take this value n multiply with the value p. Okay, so by right, you will have 4.5. Okay, so you use this 4.5 million divided by 1 million. So you're having 4.5 here as a lambda in the Poisson distribution. Okay, then an extra information here. Since this binomial is a discrete random variable, and also for Poisson, it is also a discrete random variable. Both are discrete. Therefore, continuity correction is not needed. Alright, so that means you can directly calculate the probability here. So I'm having x greater equals to 4. So to calculate the probability for x greater equals to 4, you can start from x equals to 4, x equals to 5, x equals to 6, x equals to 7, and so on until infinity. So it is very long. Therefore, we have to take 1 minus the probability that x is smaller than 4. So x is smaller than 4 means that you start from x equals to 0 first. So I'm having e negative lambda for the formula of Poisson distribution, yeah? So e negative lambda. When x equals to 1, it is always a 1. When x equals to 2, it is always a 4.5. When x equals to 0, it is always a 1. When x equals to 1, it is always a 4.5, which is a lambda. When x equals to 2, you will be having lambda square divided by 2 factorial. Then x equals to 3 is lambda power 3 divided by 3 factorial. So when you want to take the minus here, right, it should be an x less than 4. That means not included the 4. So I should put the 3 as the last term here. X equals to 3 as the last term here. So just try to press calculator a bit. You should get a very long answer. Okay, then of course you have to change it become 3 significant figure, right? So it should be 0.658. So basically, this is how we solve question number 1. Right, so now we are at question number 2. We are given the length of a random sample of 50 rods. Roads in a certain region were measured. So using the result, there's a 95% confidence interval for the mean length in meters is given. Okay, so you will get 245 and also 263, where the 245 is the lower limit or the lower value for the confidence interval. Then the 263 will be the upper value for the confidence interval. So first question, they want us to find the mean length of the 50 rows in the sample. So when they're talking about mean length for this 50 rows, right? So basically it means that they want us to find the sample mean. Okay, so how can I find the sample mean? And we are given this value 245 and also 263. How I get this 245, 263, yeah? So the 245 is the formula of x minus, sample mean, x bar minus the z multiply with standard deviation over square root n. And then for 263, the formula is sample mean plus z sigma over square root n. So between these two values, right, you will realize that between these two values, the center here is actually the sample mean. Because sample mean minus this whole thing, you get a lower limit. And then sample mean plus the z sigma over square root n, you get the upper limit. So by right, the midpoint of these two values is the sample mean. So to calculate the mean length, it will be very simple, where you try to find the midpoint of upper limit and lower limit. So you'll be having 245 plus 263 and divided by 2. Okay, so from here, by right, you should have 254 as your sample mean for these 50 rows in the sample. Okay, then let's have a look for part B. Calculate an estimate of the standard deviation of the length of roads in this region. So to get the standard deviation, I have to use back the information given in the question again. So I'm having two values here, lower limit and upper limit. So if you have a look for the lower limit formula, okay, so for lower limit formula, you compare 245 with this particular formula. So let's check. Sample mean, I already have the value for sample mean. I have the value for sample size as well, right? For the n. For the z, I can find out the value by using a 95% confidence interval. And I can find the z from the normal distribution table. So I left only the standard deviation to be found. So I can use this formula, okay, and try to find out the standard deviation here. So of course, if you want to use the upper limit, also can. By right, your final answer should be the same. Okay, so for me, I'm using a lower limit here. So where sample mean minus the z multiply with sigma over square root n, and I compare it with the lower limit for this confidence interval, which is 245. Okay, so let us put in all the value first. Okay, so I'm having the x sample mean 254 minus the z. So I want to find the z. How can I find the z here? Again, according to a normal distribution table, you're having 95% confidence interval. So the 95% confidence interval means that in the normal distribution table, right, your 95% is in the middle. And then this side is 0.025. This side is 0.025. So to find out the z, basically this is the value of the z. So to find this value of the z, you need to consider the whole area below the z. So the whole area below the z means this whole area here, the black color one. And then you should add them together like 0.025 plus 0.95. So you get 0.975. So to find out the value of z, you have to find out the table in the reverse way. So I'm having the probability 0.975. Go to the table, looking for the shortcut table first every time if possible. Alright, and then you have a look. Is there any 0.975 can be seen? So this is the 0.975 here. And what's the value of z given in the question? So in the table, so the value of z basically is 1.96. So what do I have here is my value of z here is actually 1.96. So I substitute it into my calculation here, 1.96. Sigma, of course, I don't know the value, divided by standard deviation of, square root of n. N is a sample size which is 50. So I compare it with 245. Okay. So trying to move all the value here and there, simplify the answer, simplify all the values and get a sigma. So by right, your sigma is also a long answer here lah, 32.469188893. If I'm using the full set of value, right, so this is the complete answer that I get. then of course my final answer I have to correct it to 3 significant figure, where sigma should be equals to 32.5. Okay, so basically this is how we find out the sigma. Let's have a look for part C. For part C, they are saying that it is now given that the length of the roads in this region are normally distributed. So state with a reason whether this fact would make any difference to your calculation in part B or not. So let's have a look for the part B. Okay, so for part B, right, we are using normal distribution to calculate all the value here. All right, and then for your information, what is the condition or what is the reason that we can use a normal distribution to find out the value? Okay, there must be a reason, right? Why I use normal distribution? Why I didn't use any other distribution to calculate it, right? So the main reason is because of, if you have a look for the population, right? When they are talking about population in this question, if you read carefully, they totally didn't mention anything about the population. So we don't know the population distribution. But for this sample, we know that the sample size is large, which is 50. Okay, so when the sample size is larger, no matter what is the original distribution for population, your sample mean, the mean length, the sample mean will be always approximately normal distributed. Okay, so even if now they say that, oh, okay, the population is normal, right? Basically, it won't affect anything. All right, so you can just tell them that there's no difference. Okay, so why there's no difference, as the sample mean is already normally distributed, and the sample size is large, right? So you can write when the sample size is large. So when the sample size is large, automatically the sample mean is normally distributed. All right, so you no need to have the statement that the population is normal, then only you can use the normal distribution to calculate the answer in part 2. Right? Yeah, so basically this is how we answer question number 2. So now we are at question number 3. There's a factory owner models the number of employees who use the factory canteen on any day by the distribution of binomial 25 and P. In the past, the value P was 0.8. A new menu is introduced in canteen and the owner wants to test whether the P value has increased. Okay, so highlight the keyword increase. This is a word to help us to set up alternative hypothesis later, right? Okay, so on a randomly chosen day, he notes that the number of employees who use the canteen is 23. So highlight the word 23. This is the observed value basically for us to calculate the P value later. So that means when he carry out the test, right, he's modeling, or maybe he's using 25 employees, okay, and then he tried to observe who used the canteen. So he realized that it is 23. Right, so use the binomial distribution to carry out the test at 10% significance level. So for this question, because you want to test on the population proportion, which is 0.8, okay, and to test the population proportion, right, we are using the binomial distribution. Okay, so let's start to set up the question first. So first step, when you want to carry out the test, you need to have null and also the alternative hypothesis. So by right, null is equals to P equals to 0.8. And then for the alternative hypothesis, like what I mentioned just now, the word increase is a keyword to help us to set up the alternative hypothesis. So increase means greater than. So you're having greater than 0.8. So this is the first step that you need to show. Okay, and next one, since they want us to use the binomial distribution, right? So we know that X is binomial distributed with the number of employee 25 in total, and the value of P should be 0.8. Okay, and how can we calculate the P value? Okay, so maybe before I calculate the p-value, I will want to draw a simple diagram for myself. Okay, so of course, this particular diagram again is not a valid diagram. It is just for a better understanding. Okay, when you want to carry out the test, right? But it is not a valid diagram. So please don't show this in the solution of your real exam. Okay, but for understanding purpose, I think it is still quite useful. Right? Okay, so if let's say I'm having x is binomial distributed, right? The smallest value is 0 for the x. The largest value that the x can take is 25. Okay, and after that you are having p greater than 0.8, right? So p greater than 0.8 is a one-tail test. Therefore your rejection region should be on the right hand side. Okay, so I'm drawing this because I want to know later how I want to compare this rejection region with my p-value, easier for comparison. Okay, so this particular area, rejection region here, it is equals to alpha, which is 10% significance level, right? So if you convert into a proportion, it should be 0.1. So that means this shaded area is 0.1, and basically this is the rejection area that we have. Okay, all right. Now let's have a look for our p-value. So how can I calculate my p-value? So to calculate the p-value, I have to use the observed value. So my observed value is 23. Okay, so x and 23. Yeah, so maybe I need to explain a little bit on the sign that I want to use here. When you want to calculate the p-value, right, we'll use greater and equal than 23. Okay, so there are some questions that you will be frequently asked, why it must be greater equals than 23. Can I use x equals to 23 or not? Alright, so again, the reason for using x greater equals to 23, it is because of I want to know the whole area above this value 23. Is it larger than the rejection region or smaller than the rejection region? So if I have the 23 here and the area more than 23 is smaller than the rejection area, then it will look something like this. Okay, so I'm drawing the square, the red color square here. It is because of it denote the whole area for x greater equals to 23. So I can compare this area with the rejection region, the shaded area. If let's say x greater than 23 is bigger than the rejection region, then it will look something like this. Okay, so when I draw, I can draw something like this, where x greater equals to 23, the whole area is more than the rejection area that we have. So this is the reason why we need to have greater equals, okay, but not the equal sign. Because if the equal sign here, if I calculate equal sign, x equals to 23, the probability that I get is only a single line. A single line here, you actually don't know how to draw it up, right? Okay, because it is not the whole area, but it is only a single probability. So it's very hard for you to put it in the diagram. If let's say you're having the area, right? So it is more direct that we can compare it with the area of the rejection region. So that's the purpose. So we are not using x equals to 23. We'll usually use x greater equals to 23 or smaller equals to 23. So now, second question is, if you already know that you have to use greater equals or smaller equals, right? When should you use greater equals? When should you use smaller equal? Usually the more direct sign is this one. You look at the alternative hypothesis. If your alternative hypothesis is greater than, then you use greater equals to. Okay, so, and it must be always have the equal sign here, yeah? Okay, so if this is less than for the alternative hypothesis, then you calculate this one will be smaller equals to. Alright, so all the details of all these tests, right, you can find out in the lecture videos in the channel. So maybe you can spend some time to go and search for it. Alright, yeah. So for this case, if I want to calculate the p-value, it should be x greater equals to 23. So let's start. How can I get the probability for x greater equals to 23? So I start from x equals to 23 first. So I'm having 25c 23. P power 23, then Q power 2. So this is x equals to 23. And then after that, I have to include x equals to 24. So the formula will be this one. You have to recall a little bit on your binomial distribution formula, yeah? And after that, x equals to 25. Okay, then after you get the formula, try to press calculator and help you. By right, you will get 0.0982 correct to 3 significant figure. Okay, so this area is particularly we call as p-value. And to make the decision, right, we actually want to compare this area with the significance level. So if you have a look and compare it, right, your significance level is 0.1, which is a shaded area here. And then if you compare it with 0.0982, right, so by right, your 0.0982 should be smaller than this shaded area, right? So that means when I draw the diagram, okay, so the red color one, this red color one will be 0.0982. And it means that the 23 should be the borderline, okay, of the whole area. And from here, you can see very clearly that 23 actually falls under the rejection region. So I hope that you can see this clearly, right? Okay, so when you try to compare your p-value with the rejection region, you know that it is smaller than the rejection region, which is the alpha. Okay, so we can actually make a conclusion from this part. All right, so you can say something like this where the p-value is basically smaller than the alpha. Okay, and then if you're not able to decide from here, then you can try to imagine this not officially correct graph. All right, so you can see from here that the 23 actually falls under the rejection region. So your conclusion will be you have to reject the null hypothesis. So when you reject the null hypothesis, what is the conclusion in the context of the question? So basically, it should be there's sufficient evidence to show that what? To show that the value p, right, has actually increased. Okay, so the p has increased. So this is how we carry out the test for a binomial distribution. Alright, so again, I want to emphasize one more time, this particular diagram, you cannot draw it in the real exam because it is not the correct diagram. But it is a very useful diagram for us to visualize should you or should we actually reject the null hypothesis or accept the null hypothesis. Okay, because from here you can see very clearly that your observed value falls under rejection region or falls under the acceptance region. Okay, right, so let's have a look for part B. Given that there are 30 employees at the factory, comment on the suitability of the owner's model. So there's 1 mark given here. Okay, so for this question, right, it is a very special question because if you try to have a look for the marking scheme, they basically give you 2 possible answers. One is suitable, another one is not suitable. That means no matter what answer you write, it is also correct, but you have to include the valid reason. Alright, okay, so it depends on how you interpret the question. So if let's say you feel that it is not suitable because of 30 employees, we are using 25 to calculate and carry out the test, right? So you can just tell them that not suitable. Okay, so because the model that we use is 25p, right? Okay, but now you are having 30 employees, therefore using this to carry out the test is not a suitable one. Okay, so if you are giving this as an example or answer, then you will be given 1 mark. And some students say that, oh, I feel that it is suitable because maybe not all the employees are going to the canteen, right? Okay, So you can just tell them that if suitable, then you have to tell them the reason where the owner knows not all employees are using the canteen. Okay, so for this question, no matter you put not suitable or suitable, basically they are all correct answer. But when you are writing out the answer here, you have to tell them a very valid reason. Alright, so don't write out both answer here. You can choose either one, okay, to write out. Alright, yeah, so this is how we solve question number 3. Okay, so question number 4. We are having a normally distributed population, and then the mean is 35, standard deviation is 8.1. So this whole sentence is talking about population. Population mean, population standard deviation. So there's a random sample of size 140, right? Is chosen from this population. So this is the n, sample size. And the sample mean is denoted by x bar. Find the probability of sample mean greater than 36. So for this question, the main keyword is sample mean or x bar. Alright, so they're talking about the sampling distribution. Right. So for the sampling distribution, you need to know that in our syllabus, our sampling distribution is always normally distributed. Okay, and usually they will make sure that the question will make sure that the population is either the population is normally distributed. If let's say the population is not normal, then they will make sure that the sample size is always large, which is more than 30. Okay, then our sampling distribution is always normally distributed one in our syllabus, right? Okay, so what is the mean for the sample mean? Mean for the sample mean will be same as the population mean, which is the mu. What's the variance of a sample mean? So the variance of a sample mean will be the population variance divided by the sample size. Okay, so before we calculate the probability, so let's find out the distribution for our question first in the sample mean. So the mean will be equals to population mean, which is 35. The variance of the standard deviation, the variance of sample mean will be population variance, which is 8.1 square divided by the sample size, which is 140. Okay, and now to calculate the probability, right? Because we know that the sample mean is normally distributed, therefore we have to change become Z. Okay, so this is standardization. So how can I change it become Z? Okay, so to change it become Z, we follow the standard formula here where you take the value of sample mean minus the mu divided by sigma over square root n. So same thing happened here. Okay, so we are having 36. I have to minus the mean of the sample mean, which is minus the 35, sorry. Then divided by sigma. So sigma is 8.1 over square root n. So over square root 140. Okay, so from here, you try to get the value of z up to 3 decimal places. So you should have 1.641, 3 decimal places, yeah? Then try to find the answer from the normal distribution table. From normal distribution table, they only show you z less than 1.461. Okay, so to find greater than, you have to take 1 minus. Right, so I go for 1.461 now. Okay, so go to our table again, looking for 1.461. So 1.46 is here, right? So by right is this value, and then 1 means this one. So you're having 9279 plus 1. So you have 9280. Okay, so you go back to our question here, you will be having 9280. So 1 minus 0.9280 and simplify, your answer should be 0.072. Okay, so this is how we find out the probability of sample mean greater than 36. Alright, yeah, so let's continue to part B. Okay, so for part B, they are still talking about the sample mean. Given that sample mean smaller than A is equals to 0.986, so find the value of A. So same thing happened here. The sample mean still having the same distribution. like what we did in part A just now. Okay, so just to help you recall back, yeah. So the sample mean is normally distributed, mean is 35, and the variance is 8.1 square divided by excuse me, 140. Okay, so to answer this question again, you have to standardize it become Z first because it is normally distributed. Okay, so I'm having minus the mean divided by standard deviation, which is 8.1, sorry, it is 8.1 over square root n, so square root 140. Then it is equals to 0.986. Alright, so to find out this particular value, you can get it from the Z, from the normal distribution table that you're looking for the Z. And then if you want to visualize it in a clearer way, that means this is actually your whole value here, like A minus 35 divided by, okay, and you know that this is the area 0.986. So actually I want to find out what is this particular value of Z. Then I want to compare with our formula here, our value here. Right? So to look for the value of Z in the reverse way, yeah, from the normal distribution table, you need to look for the whole area below, right? Okay, so 0.986. So you need to find out the probability from inside to outside, because inside is the probability, outside is the value of the Z. Okay, so 0.986 again. Let me clear everything first. Okay, so looking for 0.986, yeah. So if you have a look in detail, looking for 986. So I think the closest value will be 9857. We are looking for the smaller one, right? So 9857 is the value smaller than 986 but closest to it. Right, so I'm looking for this one, 987. Then if you try to read out the value, what do you get here is you should get 2.19, and then you need to add a 3, right? So when you want to add a 3, the last digit number will be either the 7 or 8. So you should have 2.197, okay, or you will have 2.198 because both are also 3, right? Okay, so these are the two acceptable value here. Okay, so if I go back to our question, I know that this whole thing is equals to 2. What is the value already here? 197 or 2.18. Okay, so when Z smaller than this value, it is equals to 0.986. So you compare this formula with either one of these value lah. Okay, so I take A minus 35 divided by 8.1 over square root 140, and I compare it with 2.197. Right, so you try to move all the number to the other side. Then by right, your A is a long value again. Okay, so of course you have to correct your answer to 3 significant figure where it is a 36.5. So this is by using 2.197. If you're using 2.198, I believe your final answer for the A, correct to 3 significant figure, also the same, which is 36.5 as well. Alright, yeah, so this is how we solve question number 4. Okay, so we are now at question number 5. There's a machine put the sweets into bags at random. So we are having lemon sweets and also orange sweets here. So in the bag have a independent distribution of Poisson with all this lambda here, 3.7 and 2.6. So a bag of sweets is chosen at random. They want to find the probability that the number of lemon sweets, so they focus on lemon sweets now, in the bag is more than 2 but not more than 5. Okay, so maybe you label the lemon sweets as L. Right, so L is Poisson distributed, 3.7 in the bag. Okay, so they are interested to find out the lemon sweets more than 2, so that means greater than 2, but not more than 5. That means it can be equals to 5 but less than that. Alright, so if you write it out in the symbol form, it should look something like this. So when you look at this one, right, basically it means that you want to find out the probability for L equals to 3, L equals to 4, and also L equals to 5. Right, so we'll start from L equals to 3 first. So you be having E negative lambda, so lambda is 3.7. Then lambda power 3 divided by 3 factorial. X equals to 4, L equals to 4, lambda power 4 divided by 4 factorial. Same thing happened for L equals to 5. Okay, so this is a formula for Poisson distribution. So again, try to use calculator and help you. By right, you should get 0.545 correct to 3 significant figure. Yeah, so this is what you have for part A. Then let's have a look for part number B. Find the probability that the total number of lemon and orange in the bag is less than 4. Okay, so highlight the keyword total. Then they are interested for one bag, right? In the bag, that means only one bag is less than 4. So total means they have to add the lemon and orange together. So I put R as orange, yeah, because O is very confusing sometimes, right? So lemon plus orange. Both are Poisson distributed, right? So when you add them together, it is still Poisson distributed. So you should take 3.7 plus the lambda of the orange, which is 2.6. And your lambda for these two total will be 6.3. And for this question, they are interested for the total sweets less than 4. Okay, so less than 4 means that you can start from x equals to 0, x equals to 1, 2, and 3 until 3, right? Because 4 is not included in this question. Okay, so start E negative lambda. When x equals to 0, you'll be having E negative lambda with a 1 always. When x equals to 1, it will be always a lambda. When x equals to 2, it will be having lambda squared divided by 2 factorial. Then x equals to 3 will be lambda power 3 divided by 3 factorial. Okay, so from here, right? Excuse me. So again, use calculator to help you. And correct to 3 significant figure, your answer should be 0.126. Right, so this is how we answer the question with the total. Right, so the total lemon and also the orange sweets in the bag. Right, so this is how we solve it. Alright, so how about let us have a look for the part C. Okay, so for part C, they are saying that now I'm having 10 bags of sweets. 10 bags. Just now all the lambda is for one bag, for a bag. Okay. Now we are having 10 bags now. Use approximating distribution. So highlight the keyword approximating distribution. That means in this question, you have to change Poisson into something else. Alright. So in our syllabus, we are having Poisson to normal. That means you have to change it become normal. To find the probability that the total number of lemon sweets, highlight the keyword total number of lemon sweets in the 10 bags is less than the total number of orange sweets in the 10 bags. Oh, okay, so they're talking about the total for 10 bags. Alright, so for this question, if you have a look and try to convert this whole sentence into a symbol, right? Probability means P, no? The total number of lemon means L, okay? But this L now is for 10 bags, lemon in 10 bags, less than, so smaller than. The total number of orange, so smaller than R in 10 bags. So the orange, I still put it as R, but this is the R for 10 bags now. So basically for this question, they want us to calculate this probability. And when you're having variable on two sides, you cannot carry out the calculation for probability. So you have to move all the variable to one side. So there are two options for you. You can either move the r over, become L minus r smaller than 0, or you can make it become r minus L greater than 0. Also can. Alright, can Okay, so before that, we have to set up our question first. So I know that at the end of this question, I want to find either this probability or this probability. Okay, so I have to set up the question first. Let us set up the L first. Okay, so for L, right, the lemon, it is originally Poisson distributed. So the mean lambda will be 3.7 for one bag. But currently you're having 10 bags. So you have to multiply with the 10. Okay, so when you take 3.7 multiply with 10, you get 37, which is already lambda more than 15. When lambda more than 15, you can change become normal distribution. And then the lambda and also the mean and also the variance are having the same value, which is both also 37. Okay. Alright, then after that for orange, originally it is also Poisson distributed. One bag is having the mean or lambda 2.6. You have to multiply with 10 also because now you're having 10 bags, right? Okay, equals to 26. So due to the same reason as well, because the lambda is already more than 15, you can change it become normal distribution as well. If your lambda is 26 here, the mean is 26, variance is also 26 for Poisson distribution. Okay, then after that, I need to combine the lemon and also the orange become one variable so that I can calculate the probability later. So how can I combine them? So this is how you need to combine them. You can take L minus R or you can take R minus L. Okay. So for me, I'm using L minus R. Okay, so which is normally distributed. Alright, and after that, what is the mean for lemon minus orange? So lemon is 37 minus the orange, which is 26. So the mean for L minus R is basically 11. Okay, then how about the variance? So the variance for L minus R will be, variance of L is 37. For variance that's no minus 1, it is always a plus. Okay, then the variance of orange is 26. Therefore, when you add them together, you'll get 63. So this is the mean for L minus R. This is the variance for L minus R. Okay, yeah, so I hope that you are fine until this part. Okay, Alright, then now we'll start with our calculation for the distribution. Right, so I'm interested for the calculation for L smaller than R, right? Originally, this is what I want to calculate. But I know that without moving the R to one side, I cannot calculate the probability. So I move the R to the other side, become L minus R smaller than 0. Okay, Alright, so this is L minus R. So L minus R, you know that it is normally distributed. Okay, therefore, to calculate this probability, you have to change it become Z, which is because they are normally distributed, so you have to change it become Z, that you need to standardize them first, then you find out the probability from the table. Okay, but the original distribution for L and also the R, they are Poisson. So when you change it become normal, okay, so Poisson basically is discrete random variable. And then when you change it become normal and combine them, right, it is actually a continuous random variable. So when you change discrete to continuous random variable, by right, you should do continuity correction. So don't forget about this, yeah? So for this variable, before I try to change it become Z, I do continuity correction here, smaller than 0. So smaller than 0, not include the 0, right? That means your calculation should be something like -1, -2, and so on. So by right, you will be having -0.5 for your continuity correction. Okay, so after you apply the continuity correction, then only you start to find out the value of z. So how are you going to find the value of z? You take the value minus the mean, so minus 11, divided by standard deviation, so divided by square root 63. Okay, then you try to get the value of z correct to 3 decimal places. So you should be having negative 1.449 correct to 3 decimal places. Okay, and after that, what should we do? Alright, so what should we do for smaller than negative 1.449? Okay, so it is equals to greater than positive 1.449. So I have to take 1 minus the probability of 1.449. So look at 1.449 now. Excuse me. 1.44 then 9. Sorry, 9. I have to make it smaller. So the 9 means 13, which means that you have to take 9251 plus 13. So by right, you have 9264. Okay, so that means in this calculation, you have to take 1 minus 0.9264. Okay, then you'll be getting this value lah, 0.736. Okay, so for this question, if let's say you are not so sure how to do the continuity correction, so again, there's a detailed explanation or detailed example lah, okay, to teach you how to make a correct continuity correction. Right, so again, you can go and search for the lecture video in the channel, right? Okay, so this is what we have for this particular question. And if you are aware of the marking scheme, you will realize that basically, right, they did also accept the answer without the continuity correction. Okay, they basically accept both. All right. They didn't tell us the reason why they accept both, but my understanding is, it is possible that they might find out that the continuity correction at the negative value, right, it seems like not logic, because we are talking about the number of streets, right? But when you make it into a negative value, it doesn't sound logic. So I think that is maybe one of the reason that we also accept the answer without continuity correction. I'm not so sure, but this might be a reason, right? If not, then maybe they just they are very kind. They at least accept both answer from the students. Okay, it is because of for this question, right? It is not a direct approximating from Poisson to normal. At first, they already changed Poisson to normal separately first. Then only they combine it together. So I think that will make a lot of students not aware that continuity correction is needed. Alright, so that's the reason also, that's a possible reason also why the marking scheme accept the answer without continuity correction. So now I will show you the answer without continuity correction. Okay, so the beginning part is the same. So that means you're having L minus R smaller than 0. If you didn't do any continuity correction, that means you can directly change it become Z. So when you change it become Z, you will be having 0 minus the mean, which is still the same, divided by standard deviation, which is square root 63. Okay. Then you'll be having Z smaller than negative 1.386. Okay, then if you want to calculate the probability, you have to take 1 minus, so 1.386. You go back to the question, go back to the normal, looking for 1.38, which is this one, 9162. Wait, yeah. 1.386, right? So 1.38. Then where's the 6? 6 is this one. It is a 10. So it will be 91 96162 plus 10. So you have 9172. Okay, so go back to the question again. Alright, so you take 1 minus 0.9172. So if without the continuity correction, right, your answer will be a bit different. So your answer should be 0.828. Alright, so if you go and double check with the marking scheme, basically they will accept any of these two answers. Alright, okay, so for me, right, I still feel that continuity correction is needed because you are changing it from horizontal to normal. So this will be, to me, this is the correct answer. Alright, yeah, so this is how we solve the question number 5. Okay, so we are now at question number 6. They are talking about the time in X hours taken by the large number of people to complete a challenge. It's modeled by the probability density function given by this. So this is a function and this is the range of the X. Okay, so A and B are constants. So state what is the constant A and B represent in this context. So A, you can see that it is the lowest limit, right? Then B is the highest limit here. So they are talking about the time. So in general, you can just tell them in the context of the question where A is the minimum time taken. Okay, to complete a challenge or to complete the challenge. Okay, where B is the maximum time taken, the longest time taken, right? Okay, to complete the challenge also. So usually when you want to explain all this, right, please make sure you explain it in the context of the question. So the context of this question, for this question, basically they are talking about the time to complete a challenge. So you have to include the word, the phrase where time taken to complete the challenge in your explanation. Okay, then let's have a look for part number B. So show that A equals to B over B plus 1. Alright, so if before you can show that, right, you have to use some properties or important information from continuous random variable, okay, then only you can get the answer that they want you to show. So there's a general formula or general property for the continuous random variable where you need to know that when you try to integrate all the x for the function fx, for the PDF function, it should be always equals to 1. So we are going to use this information here, okay, and apply in the question, and I believe that later we can prove the equation that they want us to show here. Alright. Okay, so let's start. So integrate, what's the minimum value for the x? A. What's the maximum value? B. What's the function here? So the function is 1 over x squared. So for me, I will write it out as x power negative 2. Easier for me to integrate later, so it is equals to 1. So integrate x power negative 2, the power plus 1 become negative 1 divided by the new power. Then you have to substitute the limit b and also a equals to 1. For me, my personal habit is, again, I prefer to simplify everything first before I substitute the limit inside. So from here, you can see very clearly that you're having negative 1 over b minus negative 1 over a equals to 1. And now I want to express my answer a in terms of b. So 1 over a is equals to 1 plus pi. I want to change the right hand side. Sorry, I want to change the right hand side become a fraction. So 1 can be written as b over b. So you're having b plus 1 here. Then a should be equals to b over b plus 1. And again, you can see that this is how we get the answer that they want us to prove. Yeah, so let's continue to part C. Part C is still in the previous page, right? Okay, so part C, it is given that the expected value of x is ln 3. Then show b equals to 2, and after that find the value of a. Alright, so again, since they give us expected value, right? So now you need to recall back again how to find the expected value in a continuous random variable. you have to integrate for all the value of x and multiply the x with the function before you integrate it. Okay, all right. So now let us start. I already know that expected value of x equals to ln 3. So when I want to integrate my function, I'll be having lowest limit is the a, right? Then the upper limit is the b, correct or not? Okay, then I want to multiply x together with my function. So my original function is 1 over x squared. Then dx equals to ln 3. Okay, so before the integration, of course, I have to simplify my function first. So I'm having 1 over x. Right? And now, how can I integrate 1 over x? So 1 over x basically is ln x. And then b, a equals to ln 3. And you want to substitute ln b first, then substitute ln a equals to ln 3. Okay, and then from the part b just now, right, you already know that a can be written as b over b plus 1. So I substitute the result in the part b into this step here. So I'll be having b over b plus 1 equals to ln 3. Okay, so what is the next step here? Alright, so I want to use the idea where if I'm having ln a minus ln b, right, I can write them become ln a divided by b. Same thing happen here, ln b minus ln this whole thing. When I want to write it out clearly, I will be having b divided by b over b plus 1 equals to ln 3. So you can cancel off the ln for both sides because both sides only have one ln with a bracket inside it. So simplify this particular part here, you'll be having b plus 1 equals to 3. And this is how you get b equals to 2. Okay, then after you get b equals to 2, then you want to find the a, right? So what's the value for a? A is b divided by b plus 1. And from here, you get your a equals to 2 over 3. So you successfully show the value b equals to 2. And at the same time, by using the result in part 2, you can get the value for the a. So this is how we get the a and b in this part C here. Then let's continue to the part D. Okay, so for part D, they are asking us to find the median of x. So to find the median of x, right? So the idea is basically your lowest limit is the a, which is 2 over 3. The highest limit is the 2, right? So they want to find the median so that when you integrate from lowest limit until the median, right, the answer, the probability is 0.5. Another option is you can integrate from median until 2 and then you let it equals to the probability of 0.5 as well. So up to you which one you want to use. Okay, so for me, I will start from the lowest limit first. So 2 over 3 until median. Median, I put it as m, yeah. Okay, right, so what is the function that we have? So the function that we have is x power negative 2. And then I let it equals to 0.5. Okay, because I know that the lowest limit until the median, right, covers 50% of the whole set of data. So we integrate from 2 over 3 until median, you will let it equals to 50%, which is 0.5. Okay, right, so again, we'll try to integrate first. So power plus 1 become negative 1 divided by the new power. Okay, so simplify the phrase first before I substitute in the limit. Okay, so you'll be having negative 1 over m. Okay, then minus negative 1 over 2 over 3 equals to half. Okay, so if you simplify slowly, you'll be having plus then 3 over 2 equals to 1 over 2. Okay, so what is your 1 over m? So your 1 over m equals to 3 over 2 minus 1 over 2. So when you simplify everything here, by right, your m should be equals to 1. So you can just tell them clearly that the median is equals to a value 1. Right? Yeah, so this is how we solve question number 6. Okay, so question number 7. This is the last question for this paper. Alright, so we are given the height of a 1-year-old trees in a certain variety are known to have mean 2.3. There's a scientist believe that on average, the tree of this age and variety in her region is slightly taller. Highlight the keyword taller. So I think you should know, right? If we want to carry out a test, this will be a keyword for us to set up the alternative hypothesis. Alright. And then they said, oh, the hypothesis test at 2% significance level in order to test her belief. Okay, so the 2.3 here basically is the population mean, yeah, because they said the height of 1-year-old tree of a certain variety. That means the whole group, okay, the big group is having this mean. So basically this is the population mean. Alright. Okay, so first of all, they want you to state the probability that she will make a type 1 error. Okay, so for type 1 error, in the continuous random variable, right? Okay, it is equals to the significance level. So which is equals to 2% or 0.02. Okay, so this is just a fact that you need to know. When you're having a continuous random variable, right? So they're talking about the heights. My heights is the continuous random variable. Alright, so the probability of the type 1 error is always the significance level, which is equals to 2% or 0.02 in this question. Okay, then let's continue further. She takes a random sample of 100 such trees in her region and measure their heights, which is h. Her results are summarized as below. So all the information provided here will be about the values of the sample. Carry out the test at a 2% significance level. Okay, so let's start. First step, of course, you have to set up the null and alternative hypothesis. So they're talking about the mean height, right? So the height of population is 2.3 meter. And she want to test whether in her region what is taller. So taller means greater than 2.3. So this is the first step. Okay. Then for the second step, we need to write a simple statement first. I have to use normal distribution to carry out the test. And how can I use the normal distribution? It is because of the sample size n is large. Therefore, we apply the central limit theorem. Okay, then the height, the mean height, okay, for the sample is approximately normal as well. So because of this, I basically can use a normal distribution to carry out the test. Okay, alright. So I have to write out this statement. It is because of, in this question, they didn't tell me what happened to the population. They didn't tell me is the population normal or not. So that's the first thing. Okay. Therefore, I look at the sample size. So sample size is a large sample size. Okay. So when the sample size is large, according to central limit theorem, the height, okay, will be approximately normal. The sample mean will be approximately normal distributed. Okay. And next one. After I know that I can use normal distribution to carry out the test, I want to find my critical value first. Alpha is 0.02. So if I try to visualize by using a diagram, where is my rejection region? So this is a one-tail test on the right. Therefore, my rejection region will be somewhere here on the right-hand side. Okay, then this is what I should have. So this will be 0.02 and this part will be 0.98. Okay, but of course you need to know that this 0.02, this shaded area will be the rejection area or critical area. So I want to know what is this critical value here. Okay, so the critical value I can find out from the normal distribution table by looking at this big area here, which is 0.98. Okay, alright. So I'm going to look for the critical value. Looking for 0.9 again. Usually we look from the shortcut table. There's no 0.98, right? Yeah, so what I have to do is I have to read the value from the table on top. Okay, so let's have a look again. 0.98. The closest value smaller than 0.98 is this one, 9798. So if you read out the value, it should be 2.05. Okay, then I have to add a 2 at the last digit. So there are two possible values here, which is a 4 and also 5. So if you simplify them, if you summarize them, it should be 2.054 or 2.055. Okay? Alright, so this will be my critical value. So it can be 2.054 or 2.055 also can, up to you, which one you want to put. Okay? Alright, so this is my second step where I try to find the critical value. Okay, then let's proceed to the third step. For the third step, I had to calculate the test statistic. Okay, so to calculate the test statistic, the formula is sample mean. In this case, they are using the H, so I don't use the X. Sample mean minus the population mean divided by standard deviation, which is the population standard deviation, over square root n. Sample mean, you can calculate it from the value here provided. Population mean is this one, right? 2.3. Sample size is 100. Now our problem is we actually don't know what is my population standard deviation. So we call this as population standard deviation or population variance unknown. When you don't know the population standard deviation or population variance, you have to estimate the variance first. So I have to carry out the step here first. Unbiased estimated variance. So do you still remember what is the formula for this one? So 1 divided by n minus 1 summation h square minus summation h square divided by n. Okay, so putting all the value here, 100 minus 1, 99. Summation h square is 580. So I will have 580 minus the summation of h, which is 238. You square it, divided by 100. Okay, so the estimated variance should be 113 over 825. Okay, so this is basically the unbiased estimated variance for population. Because in this question, our population variance is unknown. So we have to estimate it first. After you estimate it, you can put it inside the calculation for the test statistic. Okay, so let's start. Sample mean. So sample mean should be 238 divided by 10. Divided by 100. Minus the mean. Mean is 2.3, right? Divided by standard deviation. So standard deviation should be square root of 113 over 825. Then divided by n, which is the sample size. Sample size is 100 in this case. Okay, so please calculate the value carefully by using calculator. By right, you should be having 2.162 as your test statistic. Okay, alright. Yeah, so you can see that this value, you are applying it here in the calculation of your test statistic. Okay, so after you get a test statistic, please put in your test statistic and compare it with your diagram just now. 2.162. Your critical value is 2.054. So 2.162 should be after 2.054. So this one is 2.162. Okay, so when you put the 2.162 inside the diagram, you can see that it actually falls under the rejection region, right? Yeah, so from here you can make a conclusion. Okay, so let's continue. Okay, so I will write like this. So my test statistic 2.162 is basically greater than critical value, which is 2.054. And from the diagram on top, you can see that it falls under the rejection region, right? So you can tell them that you reject the null hypothesis. Then again, don't forget to write out a conclusion statement in the context of the question. So you can just tell them that there is sufficient evidence, okay, so to show that the trees in the scientist region okay are slightly taller. So I just try to copy what they want to prove lah, right? So are slightly taller than in other places. Than in other places. Yeah, so this is how we carry out the test for this question. And then to me, right, I think this is a bit special because of the population variance is unknown. Therefore, you have to estimate the population variance first before you can calculate the test statistic. Right? Yeah, so let's have a look for the last part. The scientist carries out the test correctly, but another scientist claims that she has made a type 2 error. So the scientist carry out the test, no problem. The conclusion, everything has no problem. But there's another scientist say that, oh, you made a type 2 error. So is it possible? Right, so let's have a look for type 2 error here. Type 2 error basically means that you accept null hypothesis when null hypothesis is false. Okay, so you will make the type 2 error when you accept the null hypothesis. But if you refer back to our result just now, you reject the null hypothesis, right? Therefore, it is impossible that the scientists make a type 2 error one. Because the type 2 error will happen only when you make a conclusion that you accept the null hypothesis. Okay, so if I want to comment on this, how should I comment it? Then you can just tell them that this is not true. Okay, so as the scientists reject null hypothesis but type 2 error, is about accept the null hypothesis when null hypothesis is false. Okay, my conclusion is reject the null hypothesis. Okay, therefore it is impossible for me to make a type 2 error because type 2 error only happen when you accept the null hypothesis. Understand what I said? Right? Yeah. So basically this is how we solve the question number 7. And this is also the end of this video. Alright, so thank you very much for watching the video.